Hello everyone. I wrote a clone of Flappy Bird in Erlang, and kind of got to do some videos on it eventually. So I should probably do them now while it's still fresh in my mind. So let's just let me just show you how it works. So we run ZX run local. Did another video on how to install ZX. So go watch that if you don't have ZX installed. So it pops up this window. I have this tiling window manager, so on whatever floating window manager it would pop out at the correct size. But I hate the floating window managers, so anyway, it says hit spacebar to play. Once playing, hit spacebar to jump. Okay, so we got the bird flapping its wings, got this stuff. The object of the game is to not hit the pipes. Yeah, I'm not very good at this. See, it doesn't store the high score on disk, but it does store it in memory. Anyway, so kind of what I want to talk about is comparing sort of the approach that there's a couple things. Number one, this isn't going to be one of those tutorials where you start with nothing and then build up a game perfectly without ever making any mistakes, because that's not really how you learn. You learn by making a lot of mistakes. So let's kill this. And actually, I want to show you something. Okay. CXH run local also pops open a shell. So if you're coming, I'm assuming probably most of you are coming from a language like Java or Python or whatever, one of the object-oriented languages. Right, so this application is called Observer, and what it has in this tab under the Applications tab under Flappy Bird, it has the process tree of my program. So you may have heard of Erlang is really good at concurrency, and you know, for a really simple game like this, you might ask, well, you know, why would you make your life harder by doing concurrency? And, well, the answer is you don't. Concurrency actually makes your life easier. That's why you do concurrency, by the way. It's not, you don't do concurrency because of performance. That maybe is a benefit you get, but the reason you do concurrency is because it makes it easier to program. Now, in particular, this is sort of the smallest example you can probably find where concurrency actually makes your life a lot easier. And in particular, specifically, it makes your life easier when you're dealing with timing. And so, you know, normally a game like this, you write it in, say, Python, you put the entire body of your program in a while loop. At the bottom, you have whatever the ticks of the game, so whatever, it's 5 milliseconds. And then there's different things with different timescales. So the base moves at a time scale, the bird flaps his wings, the bird has gravity, that all depends on time, the pipes have to move, let's see, the GUI has to redraw the screen, and there's a lot of timing going into the game. And all these things, well, the pipes and the base moving, those are on the same timescale. But the bird flapping his wings, the gravity, the controller updating the state, the GUI redrawing the screen, those are all different timescales. So let's go over what each of these processes are, and I think that'll be it for this video. I am going to kind of go more in sequence with how I actually wrote the program, and because that's the easiest structure to follow. But this is going to be a high-level overview of kind of what the end result ended up being. So there are 14 threads here. These first two are started up by like Erlang and probably ZX. I'm not actually sure how that works. This is a supervisor. Supervisor starts up a bunch of child processes and then has rules about, well, how does it react if one of the child processes dies. There's 4 immediate children. So the base, the bird, the controller, and the pipes. So the base is this thing at the bottom. The reason this is complicated enough to be a thread, general rule of thumb, anything that is an object, or anything that's complicated enough to warrant the object abstraction in Java or Python or whatever object-oriented language, that should become a thread in Erlang. And one thing you'll discover is threads kind of accomplish what objects are supposed to accomplish, but threads have a lot of really important advantages, namely that threads can crash and not, if there's a bug in whatever, if there's a bug in the controller, well, the controller maybe is a bad example, but if for whatever the bird thread there's a bug in there, it doesn't have to crash everything else. And so in a really large program, so say you have a multiplayer game and you have a chat server as well as your game, so you have a game and then maybe you have audio chat and then you have text chat. There's no reason that, say, if there's a bug in the chat server, then it should crash everything else. If the chat server crashes, then the chat server crashes. End of discussion. You don't need to make it more complicated than that. And that's really the advantage of concurrency. Well, and also particularly here, so these are timers. So these are threads that just sit there, they get a message, and the message says, send me back this message after this amount of time. So the base will send a message to this timing thread and say, send me back a message after whatever, 10 milliseconds. And then when it gets the message back, it says, okay, I'm going to move myself 5 pixels to the left, whatever it is. And then the reason this is a thread is, well, whether or not it ignores that message depends on the state of the game. So notice right now the base isn't moving, but if I press N, the base is moving. So the base, what it does in response to stimuli depends on state. That's why it's complicated enough to need a thread. Same with the birds. And so notice the bird, gravity isn't doing anything, but he is flapping his wings, whereas if he crashes, he has to stop flapping his wings. And collision detection could probably be a little bit better, but it doesn't really matter. There's 2 ticks here, or 2 timing modules, timing threads, sorry. One of them is gravity, one of them is flapping his wings. Controller, this timing module up here is update the global state. This one is redraw the screen. This one is move the pipes. This one is move the base. And then the pipes are complicated enough because, let's see. So really there's only 2, maybe 3 pipes. I might have put 3 pipes in. And all that happens is when it goes off the end of the screen, it spawns a new pipe off the right end of the screen. And I tried to dynamically generate pipes, and it was just a disaster. That's one thing we'll get to eventually. So I'm going to finish this one off by we're going to look at the getlog. And we're going to go to the bottom. So start off by creating this. I added the sprites. I stole those from Tech with Tim, I think. I'll put a link in the description. I stole those from Tech with Tim. That's where I got this idea. Code cleanups, draw the background image. So that was me figured out how to draw the background on the screen. Got the bird flapping his wings, got gravity, did boosting, so when you hit the spacebar the bird has to jump. A lot of ticks, get wing flapping, the velocity, so the angle, the bird, if he's flying, he's tilted up, if he's falling, he's tilted down. But then when he's falling, maybe go back and look, when he's falling, the wings are stationary because he's gliding. Make the bird movement a bit more infuriating. That was a minor change to the data structure of the bird, some kind of minor changes to the data structure. Then this was me trying to figure out the pipes. This one is called pipe cancer. This is where I finally abandoned trying to generate pipes dynamically, and I would run that, but last time I ran it, it crashed my computer because the code is that bad. I'm not kidding. I botched an entire recording of me. It botched a previous take when I tried to show this, and it literally crashed my computer. Delete the old pipe stuff. And by the way, this is Linux. This isn't Windows. This isn't some garbage operating. This is Linux. It managed to crash Linux. That's how bad my code was. Still filling out the pipe skeleton. Pipes on the screen. Finally, it redid the pipes, it looks like. And then blitting. Okay, so let's check out this one and show you what it is before blitting. So blitting, you'll see what blitting is immediately. What? There we go. Okay, so I hadn't done collision detection apparently, but you see there's all this flicker, and that's because it is literally, while it's in the middle of redrawing the screen, it's showing the partial redraw. And so you get all this flickering because it hasn't finished redrawing the screen, but it... So the way you fix this is blitting. So where is blitting? Yeah, blitting. And so what blitting is it draws the screen in somewhere in memory and then swaps the pointer to where the... I actually don't really know how it works. In Wix, it's all some object nonsense. So this is just literally the entire way the game works. Is it's WX Wix spawns a frame, draws a bitmap inside of there, draws the bitmaps, and then does that, whatever, 30 times a second. Blitting is it draws it off the screen and then shows it once it's done. That's what blitting is. Collision logic is pretty easy. That's the easiest part of this by far. Cleaning up. Oh, so you notice here. Notice how it doesn't have that initialization state. It just drops you right into the game. So I actually had to kind of rework the startup logic and some of the... I had to rework some of the startup logic of the program to make it so that it didn't just drop you right into the game, then had the game over state, then scoring, so figuring out how many pipes you passed. Chicken dressing, so chicken dressing, that means, like, you know, the stuff like the font and making it look a little bit nicer. Then the new game, the final score, and the high score features, that was the last commit. So there, that's a sort of overview of what this entire series is going to be. This game is really, really simple. You can go read the code. Links to the GitHub and all the things you will need to download are in the description. Thank you.